In this tutorial, we're going to give you a detailed overview of the Profile Toolpath strategy. We'll walk you through all of the options that we have available when creating Profile Toolpaths, and we'll be demonstrating all of the features in both the standard and the advanced form to help you understand the various options and their benefits. So let's go to File, Close, and we'll begin by creating a new file. Here we're working with a single-sided job, a width of 12 inches, a height of 12 inches, and material thickness is going to be ½ inch. We'll set the Z0 position of the material surface, and our XY datum position will go in the lower left hand corner, and then we could go ahead and press OK. So we're going to start by drawing a simple rectangle to demonstrate the Profile Toolpath. So let's go over to Create Vectors and use the Draw Rectangle tool. Okay, so here we're going to go with a width of 6 inches, a height of 6 inches, and then we're just going to position that in the center like so. And then we can close out, and I can switch over to the Toolpath side of things. First thing that we need to check is our material setup. So here we've got material thickness of ½ inch, XY is the lower left, Z0 is on the material surface. Check over your rapid Z gaps above the model, your clearance and plunge, home and start position, ensuring everything is safe and appropriate for your particular machine, and then you could go ahead and press OK. The Profile Toolpath will cut to and from a specified depth and will follow along the outside, inside, or on a selected open or closed vector. So this toolpath is perfect for cutting out objects, but it can also be used for engraving text onto the material surface. So the Profile Toolpath can be found in the Toolpath operations, so the first icon here, Profile Toolpath, and if I click on that, that will open up the 2D Profile Toolpath form. So this is the basic 2D Profile Toolpath form, and if we check this option to show advanced toolpath options, then we have much longer list of variables, and it just gives us more detailed options to enable us to have more control over the Profile Toolpath. Now for the first part of this tutorial, we're going to switch off the advanced options. We're just going to look at the basic settings. So let's start at the top of the form with the cutting depths. So the first option we've got here is the start depth. Now you never need to alter this if you're cutting from the material surface, but if you were cutting into a pocket where material has already been machined away, then you'd need to specify the start depth to how far into the material you want the toolpath to start from. In this case, we're going to leave that at 0 at the material surface. Then you move on to the cut depths. Okay, so the cut depth is how far into the material you want to cut your profile. Now in this case, we want to cut this square out of our material block. I know my block is ½ inch, so we're just going to leave that as it is. A top tip here was if you've forgotten how thick you'd set your material in your material setup form, you could simply enter the formula Z followed by the equals key, and the software will auto fill that information in for you based on the Z parameters that you set for your material in the material setup form. Next in the form, we need to specify a tool that we'd like to use to cut the square out. Currently we have no tool selected, so we need to use the select option here to open up the tool database. Here we have a set of default tools appropriate for hardwood and a large format CNC machine. In this case, we're just going to go with a 1/4 inch end mill here. Here I'm displayed all of the tool information. I can edit the tool. I could look at adding new tools also. So we're going to use the select option here. We also have this edit option here, and if we click on that, that will open up the edit tool form. And this is handy as it allows me to edit settings for this particular toolpath so that we don't overwrite the default settings that are in the tool information in the tool database. And if we created further profile toolpaths in the same session, it will remember any edited information we gave that specific tool, and so it's always good practice to check the tool information using this edit option to ensure that the settings are safe for that particular toolpath. In this case I'm happy with what we've got here, so we'll go ahead and press OK. Now we need to tell the software how we want to machine the vectors, whether that's on the outside or the right, inside or the left, or on the vectors. And this graphic demonstrates effectively where the tool will go. Currently this is on the outside, so it's going on the outside of our vector. Inside, that means that the tool will cut out inside of the vector, and then on is where the center of the tool will follow along the vector itself. Now in this case we're just creating a simple cutout, and I want to maintain the dimension of the square, so we're going to use the outside option. Then we have two direction options. We have climb and we have conventional. And this is down to the way the cutting teeth on the tool engage with the material and the way that chips are removed and deposited. There is plenty of discussion on which is best to use, as one may give a better finish than the other, and the best advice that I can give you is to run test cuts on your material first. If you find that the finish looks better on the waste material on the part that you're cutting out, simply switch the direction to the other option. In this case I want to use the climb option here. We could come down and use the option here to calculate the toolpath. That will automatically open up the preview toolpaths form, and it automatically put me into the 3D view. And here we're actually displayed the toolpath. So if we just tilt our view over here, okay, so we can see our X0, Y0 origin here. So tool is going to start from here, it will travel over, and then it will plunge down into the material, and then it will create the first pass. So it's going to go around, and when it gets back to the start point, it's going to plunge down further into the material, and it's going to go around and create the second pass, and it'll plunge down again, and then it'll create a third pass, and once it reaches that start point again, it's going to plunge down for the final time to create the final cutout pass, and that will cut our part out of the material. So how do we control the pass depth of our profile cutout? So let's go back into the profile toolpath form by double clicking on profile 1 here. Now if we go over to the tools section, this is where we can have the option to edit the actual pass depth. Now if we use select to open up the tool database, we can see that the pass depth for this tool is at 1/8 of an inch. Okay. Now if you didn't want to alter the pass depth for the tool in the actual tool database, but you just wanted to alter it for this particular toolpath, then we'd use the edit option here, whereby we could look at maybe increasing this to 1/4 of an inch if it was safe to do so. So here I could go ahead and press OK, and then we could just go ahead and calculate that, and we can see now that we're actually cutting this in 2 passes. So the tool's going to come over, it will plunge down by 1/4 of an inch, and then it will cut the first pass out, and it will plunge down again a further 1/4 of an inch, where it will be cutting the actual part out of the material. So we could go ahead and preview that toolpath, and we can see our square there. And if you wanted to, you could double click on the material that we don't need, and that will delete that waste material, so we're just left with the part that we wanted to cut out. Okay, so we're just going to reset this preview, and we'll just put that back in Z, and we're going to go back into the toolpath. So if we just use the select option here, we can see in our tool database that the pass depth hasn't changed for this tool, and that's because we use the edit option to edit the pass depth for this tool for this particular toolpath. So the next option in the form is to add ramp plunge moves. And so what this will do is, rather than plunge the tool directly down the Z-axis into the tool's pass depth, which can be quite strenuous on the tool, the ramping option will allow the tool to ramp into the material, which means that it will cut down to the specified pass depth in a zigzag motion at a distance that we specify here. And so it adds a horizontal element to the movement, improving the wear and tear of the tool, and it enables for faster plunge rates. So here we're going to check the option to add in a ramp plunge move, and we're going to put in a distance here of quite a large 3 inches. And so that is quite a long ramp into the tool's pass depth. And so we could just go ahead and calculate this. Now if we take a look at our part in the x-axis, we can see the tool's going to come over, and then we'll plunge down to the material surface, and then you'll see here we have these aqua lines, and these aqua lines represent the ramp. Okay, so we're ramping in 3 inches and then ramping back on itself to reach the 1/4 inch pass depth, and then the tool will cut the square out for that pass, and then the tool's going to ramp again 3 inches across and 3 inches back on itself until it reaches the final 1/4 inch pass depth, and then it will cut the square out. Okay, so in this case, for what we're cutting, 3 inches is actually quite long here. So we're just going to go back into our profile toolpath, and we're just going to change this now to 1 inch. We could go ahead and press calculate, and so now you can see that we're coming in at a much steeper angle, and we're just going to ease into the pass depth there. Right then, so let's preview that. We'll put that in Z, and then we'll just slow that down just so you can see the ramp. Okay, so it's coming in. You see that zigzagging back and forth there, so you'll see it now, and then it will cut the part out. Now if we didn't have a vacuum hold down system in place on our machine, then this square is more than likely to fly out of place on the last pass because there's nothing to hold it still. So if we didn't have a vacuum hold down, we could look at using the option to add tabs to the toolpath. Now tabs are small strips of material that hold the part we are cutting out to the material block we are cutting into. Where you'd manually remove the tabs yourself using a chisel and a hammer to break the part away from the material block, and then apply some hand finishing to remove any evidence of the tab being there in the first place. So let's just go ahead and reset the preview, and then we'll just double click back on Profile 1 to open up that Profile toolpath, and we'll just open up the 2D view on the left. So to add tabs to the toolpath, we must check this option here to add tabs to the actual toolpath itself. Here we specify the length of the tab along with the thickness of the tab. In this case, I'm going to go the length of 1/2 inch with a thickness of 1/4 inch. So these are quite hefty tabs, and this is purely for demonstration purposes. Then you use the option here to edit the tabs, and that will open up the toolpath tabs form. So the first option we have is a constant number where we can enter how many tabs we want to put in, and the software will automatically place them onto our part. So in this case we could use the arrows to choose a number, or we could simply type in a value by highlighting the current number and then entering the value that you want to use. So in this case I want to use 4 tabs, and then use this option here to add the tabs. Okay, so you see that it's added those tabs on the corners. Okay, now this may not be an appropriate place, so what we could do is use this option here to uncheck first tab at machine and start point. Uncheck that, then we use the add tabs option, and you can see that they've been positioned equally around our part. Now to delete all of the tabs, you can use this option here, delete all tabs. Now we're going to look at this option here. So this is where we specify a constant distance between the tabs. Okay, so here we could specify that we want a distance of 2 inches, and you can specify a minimum number of tabs and a maximum number of tabs. So here we'll just use the option add tabs, and you can see that it will just position the tabs at a distance of 2 inches between each one. And so it's entered 10 tabs in here because we have a max number of 10. If we delete all the tabs, and then let's just make that 8, and then use the option to add the tabs, you'll see that now we've got 8 tabs positioned 2 inches apart from each other. Okay, so let's just delete all of those tabs. You also have the option to just add in your own tabs. So if I use my mouse, you'll see that my cursor is displaying a tab symbol with a plus next to it. And if I hover over a vector, a check will appear telling me that I'm able to place a tab here. And so I can click and that will add the tab, click, click, and click. If I wanted to move a tab, I can simply take it, hover over it. You'll see I've got two arrows with an X in the middle. That's just telling me that I'm able to drag that by using the left mouse key and moving my mouse. I can move that into any position that I wanted to. If I didn't like a tab, I could just click on the tab to delete it like so. So let's just go back to the constant number 4, add tabs so that they're in position there. And again, if I wanted to, I could just click on these to delete them or click and drag them to move them around. So let's close out of the Toolpaths tabs form, and then now we can go ahead and calculate this. And if we just take a look at this in the ISO view, if we just move that over a little, we can see how this part is going to be cut out. It's going to travel over, plunge down, ramp, zigzag ramp into our first pass step, then it will go around, and then it will zigzag ramp into the second pass step, and then it will come over, and you'll see here we have a retract, and that is for the tab, and it will go around and it will retract again for that tab, and so on. Okay, so let's have a look at the actual preview there. So if we just preview that toolpath, we'll just speed that up so we can see what that looks like. We'll put that in Z. Okay, so we've currently got a global fill colour on there. That's why we're seeing the tabs as a yellow colour. So we're just going to change that back to the material colour there. And so there we can see our tabs. As I said, they are quite hefty tabs. We wouldn't probably have such a thick tab in this instance for this example. We're just showing you how to create a tab here. So that covers all of the basic options. So now let's explore the advanced options. So we're just going to reset this preview, close out of the preview toolpaths form. We're going to right click on this toolpath, and we're just going to use the option to delete this. Let's go over to the 2D view, and then we'll switch over to the design commands. So now I'd like to add in a few more shapes to our work area. So we're just going to take this square, and we're just going to use the up arrow key just to move that up a little bit. I'm going to come in, I'm going to draw a circle, just going to put that somewhere like that, and then we're going to close out, draw a rectangle, just sketch in a rectangle like so, and I'm going to take that, hold down Control and Alt, I'm going to create a copy of that rectangle that's going to sit outside. Okay, so these are the vectors we're going to use now for the next part of the demonstration. So let's switch back over to the Toolpaths tab, and then we'll go into the Profile Toolpath, and then we're going to look at the Advanced Toolpath options. And if we check this, you'll see that our Profile Toolpath form has much more options here in order for us to really control what happens to our toolpath. And we'll discuss everything throughout this tutorial. Now, in terms of our vectors that we've got here, I want to profile around the outside of this square, the outside of this rectangle, and then I want to profile on the inside of this circle and on the inside of this rectangle here. Now, you might assume that we'd need to create two separate toolpaths. So one where we'd use the outside, and then another one where we'd look at using the inside option here. So we're just going to select all of the vectors just by box selecting them, and then we're just going to see what happens if we choose to machine on the outside of all of these vectors, just using the settings that we did previously. So here we'll go ahead and press calculate, and we're just going to go ahead and tile our windows. And so looking at the toolpath drawing in the 2D view, we can see for the square we've got a start point here, and our arrows are showing us the direction of travel. And so here we can see the square is being machined on the outside, the rectangle, we can also see that that's going to machine on the outside of that rectangle. And then for the circle, we can see our start point here, and we're traveling around in this direction, and it's cutting on the inside of that vector. The rectangle here, we've got the start point traveling in this direction, and again we are machining on the inside of that vector. And so the software has cut around the outside for the outermost vectors, and if the software finds vectors inside of those vectors, then it will cut on the inside for the internal vectors, which is exactly what we want here. The Profile Toolpath knows that if it finds any vectors inside other vectors, to machine those vectors on the inside, to cut those out while still cutting the outside of the outermost vectors. Okay, so let's just double click to go back into the Profile Toolpath, and we'll look at some further options within the Advanced Toolpath Options form. Now if we go over to the Edit Tool option here, we just click on that, we can see that currently our pass depth is at 1/4 inch. We can see over here we're displayed the number of passes, and so to use this tool with these pass depth settings, it's going to take 2 passes to complete the cut depth of 1/2 inch. Now if we change that back to 1/8 inch and then go ahead and press OK, you'll see that that number has now changed. It's showing that we're going to cut that in 4 passes, and so the software will evenly distribute the steps as long as they do not exceed the pass depth set for that tool to complete the total cut depth. And we have this option here to customize our pass depth. So if we click on the Edit Passes option, that will open up the Specify Pass Depths form. And at the top of the form, we're told the total depth of cut, which is 1/2 inch, which is what we've specified here in our form, and that is our material thickness. So in this case, we want to cut all the way through our part. To the left here, we're presented with a graphic that shows the position of each one of these passes relative to our material. And I can select a pass by clicking on the actual pass depth value in this form here, or I could also look at actually selecting the line in the graphic like you can see there. We can also look at deleting pass depths, so you can simply select a pass depth either from the value or by selecting the line itself, and then use this option here to delete it, and you'll see it's been removed from this list and the line has been removed from the graphic also. We can also look at selecting a pass depth and manually changing the value of that. So for this 1/8 inch pass depth, we can come in over here and we can actually change that. We'll say we want to make that 1/4 inch, and then we'll go ahead and press apply. You can see it's been updated here in our list, and the graphic has moved to the position where 1/4 inch would be relative to this material thickness. Now the pass depth defaults are all being populated using this calculation here, which is using the actual pass depth of the tool, so the 1/8 inch, and it's going to create the pass depths up to the depth of cut, which is the 1/2 inch that we specify in this form. And so we know that 1/8 inch fits into 1/2 inch 4 times, but we're not left with any small remaining pass at the bottom. Now what happens if we change our pass depth to just under 1/8 inch? Do we end up with 5 passes? So let's cancel out of the form here, then we're just going to go to the edit option here. For the pass depth, we're going to change that to 0.124, and then we could go ahead and press OK. And then you'll see that the passes are still being displayed as 4 passes. So let's go into the Edit Passes form. And so we can see that that 0.124 is being picked up here. But it's still saying that it's going to calculate this at 4 passes at 1/8 of an inch per pass. And it's done this because we have this option here to maintain exact toolpath depth, and that's unchecked at the moment. And if the software detects a minor last pass depth that could be shared out equally in minute amounts to other previous pass depths to reduce the passes from 5 to 4, then the software will. However, if you wanted to maintain the exact toolpath depth, then you could check this option here to maintain exact toolpath depth, and then use this option here to set the passes, and you'll see that it will update that now to 5 passes, where each pass is at 0.124 and the final pass is a very small 0.004. Now, I don't need to set my pass depth to 0.124, so I'm actually going to turn this option off and then use the set passes option just to reset that. Another way to specify the number of passes, and another way to populate the passes the tool will take to cut through the material, is by specifying the number of passes in this box here, where we could use the arrow keys, and with each arrow key you'll see that the graphic and the form is actually being updated. Or I could simply just type in a value, say 8 in there. It's telling us it's going to do that 8 passes at 1/16 of an inch per pass. And then we can use the option here, set passes, and the graphic has been updated along with all of the values in the form here. And so the software will just create equal passes to the number that we specify in this option here. So we're going to go back to 4 passes here. And then we're just going to OK out this form, and you'll see that the 4 has been updated here. So now we're going to look at the next option that we haven't covered yet, and that is the allowance offset. So you can add in an allowance offset where we can leave on or take off extra material. And so you'd enter in a value here. Now a positive number would be an undercut, so we'd be leaving more material on our part, whereas a negative number would overcut, and so it would cut past the vector. So let's start with an example. So we'll put in an offset of 1/4 of an inch. That's the same distance as the diameter of the tool that we are using. And then what we could do is we could go ahead and just press Control and calculate. Okay, so that's just going to update that without going into the preview toolpaths form. And we can see that's been updated. Okay, so it's a little tricky to see the actual tool path here using this option. So we're going to go up the top, and we're just going to switch on to toggle the solid view this time. Okay, so this purple colour actually represents the cutout of the part. So anything that's purple will be removed away from our material. And we can see there that we have a distance here, and it's cutting away from our original vector by 1/4 of an inch. And the same applies on the inside also. So we're creating extra material, leaving more material on using a positive allowance. And then what we could do is we could look at the results of a negative cut. So here we're going to go negative 1/4 of an inch. Again, press Control and calculate, and here we can see that it's cutting now pretty much on the inside. So originally we had our toolpath set to cut along the outside, and we've created a negative offset where we're cutting into our part by 1/4 of an inch, so it's moving in there, and you can see we're going to remove much more material here. And so if we go ahead and just calculate that, and then we'll preview that toolpath, you can see how much more of that material has now gone. And so something like this, using a negative allowance, would be very handy when working with slot together projects. So let's just go ahead and reset that preview, close out of the preview toolpath form. We're just going to double click back into our profile toolpath. We're just going to reset this allowance offset, put that back to 0, and now we're going to look at this section of the form, which is a separate last pass option. So in order to get a very consistent and clean profile to the edge of the part, you may want to do a separate last pass, where you'll leave on a small allowance which will cut the profile toolpath at a small allowance that you set here in the form. And by doing this, we're keeping the tool away from the finished part by a small distance, and then we can remove the fine shaving of the allowance across the full depth with a separate last pass. So you may want to use this to eliminate witness marks created from each pass depth where you've cut down in stages. So let's switch this option on and we'll put in an allowance of 0.01, so a very small allowance here, and then we could go ahead and press calculate. Okay, so in the 2D view we're currently looking at a solid preview for our toolpath. We're just going to toggle that over to a wireframe so that we can see the actual wireframe and the arrows of the direction of the toolpath, and we're just going to zoom in here on the 2D view. Okay, so you can see that we actually have two paths here. So the first path is undercutting by the 0.01 allowance, and it will cut all but the last pass, and then this pass here does the final pass, being the only pass which cuts to size. And so what it does, it uses more of the length of the cutting teeth to machine away the tiny amount of material that is left on for the last pass, and we reduce the amount of witness marks on our part. So you need to be aware that the tool you are going to use has cutting teeth at least equal to the full depth cut. Otherwise you may risk the tool and the machine damage from forcing the tool shank into the material. And this really is a nice feature to use to create nice clean cuts. So if we just go back into the profile toolpath, you'll see that we also have the option to reverse the last pass, which again goes back to the climb and conventional debate, which is all down to the way that the cutting teeth on the tool engage with the material, and the best advice that I can give you is to run test cuts on your material first. So if we check this option here and then just use the option to control and calculate, you'll see that that has now been reversed. Okay then, so we're just going to switch off the last pass option, and then in the 2D view we're just going to go over and use the option to zoom active view to the drawing limits. We'll close out here and we'll just undraw that toolpath, and we'll just go back into the profile toolpath. Now you'll notice that in the tab section we have another further option now that we have the advanced toolpath options open, and that is the ability to add in 3D tabs. So if we check that option there, you'll see that we're now able to select the 3D tabs option. Now 3D tabs are quicker to machine as the tool doesn't retract, where 3D tabs are triangular rather than rectangular. So with that option on, we'll keep the same length, same thickness tabs, and we'll just keep them in the same position. And then we could go ahead and calculate that just to see how that looks. And if we have a look in the 3D view here, we can actually see the triangles of those tabs. And so if we go ahead and preview that, okay, and then we'll just put that in a view where we can actually see those triangles there. And so we can see that with the actual toolpath itself, what's happening is the tool ramps up to the height at the top of the triangle over half of the distance, and then it goes back down again to actually create that triangular tab. Okay, so we'll just put that back in the Z view, and we'll just undraw that toolpath, and we'll double click to go back into the profile toolpath form. So now we're going to look at the ramp options. Now we've seen in the basic form the option to specify a ramp distance. Here in the ramp section we have much more advanced options to apply in our ramp moves. So we're going to check this option here to add ramps to the toolpath. You've got three options. You've got smooth, you've got zigzag, and we've got spiral. So we'll start by looking at the smooth option first. So the smooth option will just follow one consistent plunge to the distance or the angle that we specify here. So let's just go with a distance here of 1 inch, and then we'll just go ahead and press calculate there. We'll just reset that preview. And then if we just take a look in the 3D view, okay, so again, those aqua lines are those ramps. So it's going to ramp in at the distance of 1 inch until it meets the first pass depth, and it will travel around, and then it will ramp in again. So let's just take a look. If we just really reduce the speed here, we can kind of see what's happening. So if we preview that toolpath, okay, so it's ramping down, it's cutting at the pass depth. As it meets the original ramp, it's going to ramp again. And then as it meets the original one, you'll see that ramp there, and it'll continue to do that pass until it reaches the final one, like so. Okay, and you'll see it will just continue to do that for the rest of those, so we can just speed that up now. So let's just use the option here to undo last, and then we'll double click to go back into the profile toolpath form. Okay, so now we're going to look at this zigzag option. So we've looked at the standard zigzag which we used earlier, where we plunge gradually like the smooth option, but then come back in the opposite direction as well. So only ever taking half of the pass depth on each ramp going into the material. So here we'll just go the same distance, and if I press Control and calculate, that will just update our preview there, and so you can see the aqua lines there of the ramp coming in at half of the pass depth and then coming back in to create the full pass depth in which it will travel down, and so on. Okay, so now we also have the other option here of creating a spiral ramp. And spiral ramps will begin at the top of the material, and as it travels around, it slowly plunges to the full pass depth over the distance of one pass until it finally reaches the bottom and fully cuts the object out. So we're going to use the spiral option. We're going to press Control and calculate, and if we take a look at the actual toolpath here in the 3D view, we can see that it's just an aqua line here, so we're just using a ramp to complete the cut there. And then if we go ahead and preview that, so we'll just use the calculate option, and then we'll open up the preview toolpaths form, and then we could go ahead and preview that. So we're just going to really slow that down, and we'll just zoom in on this area over here just so we can get a better view of what's going on. And if we preview that, you can see it's just ramping down continuously around the part until it reaches the full cut depth of the actual cutout itself. Now you're probably wondering what happens if you have tabs in place. Well, if we take a look, we just speed this up. We know that we've got tabs on the top there, and if we just come out just to take a look, you can see it has included those tabs. And if we just switch on the actual toolpath itself, you'll see that even though it's ramping across, it can see the tabs in there, and so it's mindful to come back up and then continue ramping down to complete the cut, along with keeping those tabs in place. And so the spiral ramp is just another way that we can eliminate the stress placed on the tool plunging straight in and removing the full pass depth all in one movement, where you're just taking away a minimal amount which will slowly build up to the full pass depth. So let's just go ahead and reset that preview. We'll uncheck the visibility of the toolpath, and we'll double click just to go back into the profile toolpath form. And you'll notice that we have the option here to add a ramp on a lead in, and we're going to come back to this shortly. So let's just switch off the ramps to toolpaths, and let's have a look at the leads section here. So the leads is where we can control the lead in and out of a job, and this can help to eliminate witness marks that may be left from where the tool plunges into the material. And it does this by using what the software sees as waste material, which is any material outside of the actual cut that you're going to use, and it will plunge into this material away from your finished cut. So we have two types of lead. If we use the check add leads option, okay, so here we have straight leads, and this is where we apply an angled lead into the pass. And then we have a circular lead where we apply a radius lead into our pass. So let's start by looking at the straight line lead. So we're going to look at using an angled lead in. So we need to specify the angle. Here we'll go with 45 degrees, and then we need to specify a lead length. In this case, we'll just go with 1/4 inch. Then we could go ahead and press calculate. Now the software has come up with a warning message telling us that one or more leads were clipped or removed. To avoid gouging, one or more leads had to be reduced in length or removed completely. Check the toolpath is still suitable for your requirements. So let's OK that, and let's just take a look at our part. Okay, so in the 2D view we can see we've got a lead in here for this part, we've got a lead in here for this part, we've got a lead in here for the circle, but we don't have a lead in for the rectangle here. That's because it won't be able to create a lead on a sharp internal corner. So to accommodate this, what we could do is we could just look at changing the start point. So if we just double click to go back into the 2D profile toolpath, so one way of doing this would be to go into node edit mode to alter the start point, or a quick option whilst we're in here is we could look at the start out options. So at the moment it's currently optimizing the start points. So we're going to use this option here to move start points to be the closest to the selected point on vector bounding box, where we could choose any one of the corners and it would start at the corner of a vector. Or we could look at the midpoints, where we could go to the midpoint of the top of the vector, the right side, the bottom, or the left side. In this case we'll go for the left side midpoint here. So we're going to use that option, and we're going to come back to the start out options to look at this in a bit more detail later on in this tutorial. So let's go back to our leads, and then we could go ahead and press calculate. So you can see the software hasn't displayed that warning message now, and we've got that lead on that internal rectangle. And so if we just zoom in to this part here, so we can see that the toolpath is now starting just outside of the intended cutout. And this is where the tool will plunge into the material, and then it will travel to the part and around the part. And then once it's done that first pass, it's going to retract that back out there, and it's going to come back over here, plunge back in at the start of the lead position, lead into the cutout, cut the next pass, and so on. So let's have a look at how this part looks. So if we just twiddle the view so we can see that a little better, and then if we just slow the speed down here, and then we can preview that so you can see that lead in there, and it's cutting the part out, and so on. It's going to take the next pass, and then it will come back out and then run the next lead in. Now the only problem with this at the moment is that when the tool approaches the end of the first pass, it's going to retract on the edge of the final part. So we may want to add a lead out also, so that the tool doesn't finish cutting at the edge of the finished product, and it will finish out in the waste material. So let's just speed that up just to complete that cutout there. And then we're just going to reset that preview. We'll just double click just to go back into the profile toolpath. And then if we go back into the leads section, you can see that we have an option to do a lead out. So this is where we can specify an overcut distance. So instead of plunging in and out of the material in the same position, we can overcut by a distance that we enter in here and then retract out in a different position. So we avoid entering and leaving the same place in our cutout. So we're going to check this option here, and then we're going to put in a small overcut distance of 1/4 inch in there. Okay, so it's going to come in, run its pass, and then it's going to overcut by 1/4 inch and then lead out, and then it will retract and then plunge back in at the lead in. So let's go ahead and calculate that. Okay, so we have that same warning message we saw earlier where one or more leads were clipped or removed. So let's take a look at what we've got here. Okay, so I can see straight away it is that rectangle again. Okay, so you can see that the lead in is much longer than the lead out. So it has been clipped, and this isn't going to cause too much of a problem. It's just shortened the length of that lead out. So I'm okay to continue here. So just put that back in Z, and then we can see all of the lead ins and the lead outs for each one of those vectors. So if we just zoom in and we'll just take a look at the rectangle like we have been throughout this tutorial. So the tool is going to travel over and then it will plunge down to create the first movement in the material outside of the actual final cutout, in which case it's going to lead in along the angle of 45 degrees, and it will run the first pass depth, and as it reaches the end point it's going to overcut by 1/4 of an inch, and then it's going to lead out and it will retract, and it will come back over and plunge down into the second pass depth for the second lead, and so on. So let's just speed that down, and then we could have a look at how that looks. So if we preview that, so there's the lead in, it's going round doing the first pass, it's going to overcut out and then lead out, and then it will plunge back into the start of the lead over here and then resume cutting. Okay, so you can see how that works. So let's just speed that preview up, and then we could go ahead and just put that back in Z, and then we could just go ahead and reset that preview, and we'll just double click to go back into the profile toolpath form. So if we go back into the leads option, now we're going to look at using a circular lead. Okay, so here we have to specify a radius. So for this example, we're going to go with a 1/2 inch radius here. We'll go the lead length of 1/4 of an inch. We'll do a lead out using the same 1/4 inch overcut distance, and then we could go ahead and press calculate. Okay, so we've displayed that warning message again, and this is more than likely due to the fact that we are trying to use a circular lead in on the circle vector, and so it will have been clipped or completely removed to reduce the chances of the tool entering the finished part. So we'll just go ahead and press OK in this case. Okay, so if we just zoom in onto the area of the rectangle there, okay, and so we can see the curve going in and it's going around, it's coming back to the start point, and then it's going to overcut by 1/4 of an inch, and then it's just going to round out, lift, come back over, plunge back into the start of the lead, lead into the part, and then cut the next pass, and so on. So again, let's just go ahead and just preview that. We'll just slow it down so you can see the round edge going in and it's coming back out again, like so. And this is a more subtle curve into the cut path, which may give you a better finish overall, as using a straight lead with quite a sharp angle may cause the machine to make a sudden turn, which isn't going to give you a greater finish as what may be achieved with the circular lead. So we'll just speed that up until that is complete, okay, and then we'll just go ahead and reset that preview, and we'll put that back in Z. Now, as I mentioned earlier, leads can also be used in conjunction with ramps. So let's just double click on our profile here. We're going to use the option to add ramps to the toolpath. We're also going to use this option here to ramp on lead. Okay, now for the ramp in on the lead, you can only apply that to a smooth or a zigzag ramp. You cannot apply it to a spiral ramp. In this case, we'll go with a smooth ramp here, and you'll notice that all of this information is now greyed out, and that's because it's using the distance information from the leads that we're using. Okay, so if we go ahead and calculate that, okay, so we have another message here to tell us that one or more leads were clipped or removed, and that's more than likely due to this circle, so we're just going to OK that. Okay, then we're just going to zoom in over here and we can see the aqua line there, so you can see that we're actually ramping on the lead in, and then if we just slow that down we could go ahead and preview that so you can see that ramp on the lead there, then we're just leading out and then ramping back in. And so with this circular lead going down in a smooth ramp into the pass, this again will just help alleviate the stress of the tool plunging into the material. So let's just speed up this preview and then we can just put that in C. We'll just go ahead and reset that, close out of the preview toolpath form. We're going to go back into the profile toolpath and switch off the tabs, switch off the ramps, switch off leads, and now we're going to look at the order section. And so this allows us to have a little bit of input in the way the software chooses the order in which it will machine them, where we can specify one or more ordering approaches to try. So we could be very specific here and we could look at unchecking all of the options and just leaving the left to right checked. And so what that will do, the software will machine all the vectors on the left hand side first, and then it will machine all the vectors on the right hand side last. We could have the option to use bottom to top. So for example, if your CNC is set up to work from bottom to top, you might have multiple parts to cut. You could set the order to go from the bottom to the top so that you can take the parts out to hand finish whilst the machine is still running the other parts in the job. And we can also select multiple options here. So we could say left to right along with grid, and then the software will just choose which is the fastest route for machining based on these items that we've got checked. Now if we wanted to be really specific, where we solely wanted to choose the order, we can look at using the vector selection order. So uncheck these options and use this option here, and so this is where it uses our selection of the vectors as the order. For example, if I select this rectangle first, followed by this rectangle, followed by the circle, followed by the square, and then if I go ahead and just press Control and calculate, you'll see it's maintained the order that I used to select, where it's gone to the rectangle first, then the inner rectangle, the inner circle, and then the outer square. Now there is an exception to the manual selection here, and that is when you have vectors inside of other vectors. For example, if I selected the square first, then the inner rectangle, then the circle, then the rectangle, the software will always machine the inner vectors before cutting the outer vectors, still maintaining the order you selected, but it will always ensure that it cuts any vectors inside of other vectors before cutting the outer vector. So you just need to keep that in mind when using the vector selection order. Another option here is the grid option, and this will join using a grid-based approach with the size of the grid based on the size of the parts. And then finally we have the shortest path option, and that will just ensure that the software will try to determine the shortest possible path. Right then, so that's pretty much the order. So now let's move on to the start at. So we briefly looked at this whilst we were looking at the lead section. And so this is used to closer control the movement from one vector to another and can help eliminate tool entry and witness marks in key aesthetic areas. So we have three options. We have keep current start points. Okay, so this is where the software will just take this start point for each vector, and this is very useful if you need to ensure that the cutter doesn't plunge onto a critical part of the job, and these can be changed if you wanted to by changing the start point in node edit mode. Now, by using the start point option, it may result in a less efficient toolpath, as you may increase the cutting times because it may take the machine longer to move between each shape being cut. Then we have the option here to optimize start points, and this is where the software will try to calculate the shortest toolpath, minimizing the distance between link up moves. But the downside is that the cutter may plunge or mark important surfaces on the machined edge. And then finally we have move start points to be the closest to the selected point on the vector bounding box, which we did look at earlier when we were on the lead section. So this is particularly useful if you wanted to alter the start point to multiple vectors in your job to a common point without having to go into each individual vector to alter them separately. So we've seen how we can use the mid left side. If we selected the top left hand corner and just press Control Calculate, you'll see that it's altered that there. We could go to the top middle, Control Calculate. We've got the middle of the top bounding box for this vector, the middle of the top bounding box for the circle, and the rectangles, and so on. And you can just choose whichever option you wanted here. So now we come to the final option in the Advanced Toolpath Options form, and that's the Corners option. So here we are able to add sharp external corners and sharp internal corners. And so to explain this option, we're actually going to use a different example where we'll look at a part that has both sharp internal and sharp external corners. So let's just close out. We're just going to delete that toolpath like so, and then we're just going to maximize the 2D view, use this option here to zoom active view to the drawing limits, switch over to the design tab, and with all of these vectors selected, we're just going to delete them. Then we're going to go into the draw text option here. So here we're just going to go in, we'll find a Times New Roman font, and we're just going to go with the letter E, close out, and then with that we're just going to scale that up like so, press F9 on the keyboard to center it, and then we'll use this letter as our example. So let's switch back over to the Toolpaths tab. And so we're using this as this is a really good example of a part that has plenty of internal and external sharp corners. So we're going to create a beveled edge around this letter using a V-bit tool on a simple profile pass, where we'll demonstrate how the corner feature works. So if we go into the profile toolpath, okay, so with that vector selected, we're going to set our start depth at 0. We're going to have a cut depth of 1/4 of an inch. Then we're going to go and select a tool, in which case we're going to use a 90° 1/2 inch V-bit. Use the select option here. We want to machine on the outside of our vectors as we want that bevel to be on the outside of our part. And then we could simply go ahead and press calculate, and then we could go ahead and preview that toolpath. And so something that was so easy to create adds a nice effect to the letter. However, if you look closely, you can see that where the tool has rolled around the internal and the external corners, it's providing us with rounded areas. Ideally, we would like to see sharp corners that the original letter has. So let's just go back into the profile toolpath. And then if we go into the corners option, we'll just start by looking at sharp external corners here. You can see the graphic there, how that changed, and this is just indicating to us how that is going to look with this option checked. And so if we go ahead and preview that, okay, so we can see the actual line the external corner has took to create this sharp corner in the path there. And so if we just reset that preview and then preview this toolpath, we can see now that on the outside edge we have all of these nice sharp corners. However, in the internal parts we can still see we are still left with a curve. There's no definition as it's still rolling around. So this time we're going to go back into the profile toolpath, go into the corners, and this time we're going to select the sharp internal corners option. And if we check that option on, you'll see that an allowance for the cutout tool has also been added here. And this isn't something that we need to specify. This is something that we actually need for when we come to cut out the letter of our material block. And so this value here is the distance from the letter to the edge of our bevel. And so that when we do come to cut the part out, we know that we need to offset our toolpath by this amount. So what we're going to do is we're just going to take this value, we're just going to right click, and we're actually going to copy that value for when we come to create the cutout pass. So here let's go ahead and let's just go ahead and press calculate. And so we can see just by looking at the toolpath, so you can see these lines here, the toolpath now taken the tool edge up into the internal corners. And if we go ahead and preview that, we can see now that the corners are much better defined, where we have nice internal sharp corners. And the software's achieved this by retracting the V bit up slowly into the corner to create this sharp internal corner and sharp internal beveled edge. So all we need to do now is run the cutout pass using another profile toolpath. So let's close out and then we'll just tile our windows. So using the same vector, we're going to come over to the profile toolpath. So here we're cutting all the way through, so I'm going to type in Z equals, and that will input the thickness of the material that I assigned to this job. Need to select a tool, so use the select option. So in this case we're actually going to try and use the smallest end mill that we have, just to prevent a noticeable radius edge around the internal corners. So here we're going to use a 16th inch end mill, so we'll select that. We're going to machine on the outside of those vectors, whereby we must enter in our offset. Okay, so here we're just going to paste in that 1/4 inch value that we got from the internal corners form, and then we can move on down, and then we could simply give that a name. We'll just leave it as it is and then go ahead and calculate that, and then we can preview this toolpath, and then we can just delete the waste area, and then here we have our finished letter E. So there we have our final cutout, where we have real nice sharp external and internal corners thanks to the corners option within the profile toolpath form. So we're just going to quickly look at one final option. Go back into the profile toolpath. So at the bottom here we have the option of how we select our vectors. Currently it's set to manual, which means that we go in and we manually select the vectors that we want to assign to this toolpath. However, we can use this option here to use the vector selector, where the vectors can be automatically selected based upon the criteria that we have within this form. And this is covered in a number of other tutorials, and you can find those in the related videos section for this tutorial. So that completes this profile toolpath guide tutorial. Thank you for watching.